Hi, this is Paul from Foresight Tech. In this video, we are going to deal with the infinite series, focusing on calculating the sum of a convergent series. Let's see the outline. First, I will introduce three basic ways to calculate the sum of a convergent series, including using definition, a linear property, or geometric series formula. Then we will practice 4 questions together about how to use those basic ways. Let's see the material. Here is the definition of the sum. And we learned this from the last video, right? So we only go over a little bit. And the series converges if the partial sum sequence converge. That's the definition for convergent series. What is Sn? Let me highlight and let's go over a little about this definition. Sn we call the nth partial sum, right? It's not the sum, just the partial. And definition Sn is this, which means the first n terms of the sequence added together. See, if the partial sum sequence diverge, this time the series we call the divergence. Okay, therefore for a convergent series and the limit of the partial sum, okay, that's the definition for the sum of this convergent series. Okay, and if the limit of the partial sum exists, for example, we say this approach S is the limit, therefore S is the sum of the series. Okay, let me give you an example. Let's look at a special case. I'm going to draw a graph for you. And this kind of special, if all the AI in the sequence are positive, imagine, and the partial sum will add more terms, the partial sum will get bigger, right? Therefore, this partial sum sequence will increase and increase. If it's a convergent, which means not the increase into infinity, but what? But approach to S, right? Let me draw this graph. Draw this here. If this is X or N, let me draw this is Sn. Okay, so first let me show if this is the sequence, the partial sum sequence S1, S2, S3, okay, the limit of this sequence is the sum of the series, right? Let me put the term. Okay, so here is 1, here's 2, here's 3, here's 4, here's 5, and moves on. Okay, where is S? Okay, of course, S is a positive number in this case. So I draw S is a horizontal line. Okay, this is S, or Y equals S. Can you see now where is this partial sum sequence? Okay, the first S1 is A1 is a little bit small, right? A little bit lower, then gets up and up and up. You know, is gets what? Gets approach. Okay, approach to this number S. In this case, we call it the sum S is the S. The number S is the sum of the series. Does this make sense? Okay, and then now let's look at another way we call the linear property. Here is the linear property, which is the second way we can use to find the sum. Okay, let's look at the results. If we have two series both converge, then and here, okay, if we times C to AN, this new series converge too. And if we add AN and BN together, this new series converge. If we minus, they also converge. And converge to where? Okay, how to calculate the new sum? For the first is just take C constant number C out. Okay, for the sum, just a break. For the difference, is just a break. Okay, do you remember this type of property? We learned this before, right? At the beginning of this integral, we learned if we do integration of a function, if the function times c, the c can take out, right? If we do integration of both functions, the sum of two functions, we can break it down into the sum of two integral. Therefore, see, and the result is very similar. Okay, why they share the same type of linear property? Let me give you a comment. Okay, and exactly the integral we learned before is just kind of series. Why? You just think about it. Okay, what is the definition of the integral? Cut the area into pieces. Each piece is at the area of the integral of a rectangle, right? See, is still a1 plus a2 plus a3 and take the limits. So they are exactly the similar. So you can say integral is kind of a series. Okay. Also another way, okay, series you also can see another kind of integral. Therefore, they share the similar linear property. Now, here I just want to prove in a simple way. Okay, I prove the first. How do you say this new series converge? And we use the definition, okay, which means the partial sum. Let me just find the partial sum of the first, which is this. Can you see? And the c times an, I change it to ai, okay, because I want to take I from the first term to the nth term. Can you see this is Sn, right? This is partial sum. We need to find that the limit of this exists. Therefore, these series converge. What is this? And easy, we learned that before. This is just factor c out. Therefore, we have this. And ai. Because this is a finite term, we can factor c out. Can you see now? Because the series an is converges, right? Therefore, this approach to c times here an. Okay, this is a number, and therefore we prove the first one, right? See, and which means the c take out. This is the limit of the partial sum. Therefore, is the sum of the series. Now is the same for an plus bn. Let me going to find the partial sum. Okay, again, so this time I still do I from 1 to n, and then I plus bi. Of course, this time easy. So finding the terms, we can merge them together. We put the a together, which is this, right? And this is just associate the a together, and then associate the b together. Okay, which means break it down. And then what? The first term porch to what? Porch to summation an, the first series, right? The first sum of the series. And the second goes to bn, because both series converge. Therefore, can you see what did we find? Now we found that the partial sum porch to a number. Therefore, this new series, this series converge to the sum. Okay, then we prove the plus. How about the minus? Of course, they are exactly the same. All we need to do, just put a negative here, put a minus. So we put a minus. This is the proof, and we can use this property, okay, to find the sum. Now let's look at the third way. Here is the third way we can use to find the sum of a convergent series. You know, this we call the geometric series, right? We can use the formula. Okay, we learned this from the last video, so we just go over a little. Can you see? Let me highlight which formula. Okay, this is the sum, right? What's a? Okay, a is the first term. Okay, what's r? R is the common ratio. Okay, that's the comments I have to give to you. All we need to find the sum. First, we need to determine series is a geometric or not. So we need to find the first term, which is a, right? See, in the formula we have a, and we find that the common ratio, see, which is r, and we have r in the formula. Okay, and of course we need to make sure this r should be belongs to -1 and 1. Therefore, the series converge. One more, we need to pay attention to the power. Let me highlight here. Okay, if we use the general formula, okay, the general term, what is the power? The power is n minus 1 is not n, right? So this we need to pay attention. Now, okay, this is the third way, and we have 3 ways so far. Okay, so let's go into practice. Here is the first question. Okay, so we need to find the sum. It says it's a convergent series. Okay, so we just learned 3 ways, right? So either we use the geometric series, or we use the linear property, or we have to use the original definition. Okay, how do we do? And this is not a geometric series, of course. It's not a linear combination, so we cannot use a linear property. So let's try the definition, okay? Which means we find the partial sum, see if we can find the limit or not. So, and let's try the definition. So what is the partial sum? I will write here Sn, which means this is sigma, I use I, okay, the first term to the nth terms. And the general term is 1 over, now is I, right, times I plus 1. Okay, how to do? We have to break down this fraction, okay, and easy to break down. I from 1 to n, and if we break it down, it's just it is 1 over I minus 1 over I plus 1. Okay, we can go to verify. And this term together is the denominator. And then this term here on the top minus this term, I plus 1 minus I, of course is 1, right? They are the same. Now, what do we do? Let me just write all the terms, see what we can do with that. This term, what do we have? Write the first term, which means take I equals 1. That's 1, right? Minus 1 half. This is the first. Let me look at the second term. I equals 2, which is 1 over 2, right? And then minus 1 over 3 now. Let's look at the third, one more term, okay? 1 over 3 minus 1 over 4. Okay, so let me continue. Okay, ignore the middle terms. Look at the last term, which is I equals n. That's 1 over what? N minus 1 over n plus 1. Okay, what do we can do now? Imagine, see, okay, all this is a plus or minus. You can just take out the parentheses. Therefore, we can look at this term. Negative half, this term. Positive half. Cancel, right? Just cancel. The same. This negative 1/3, positive 1/3, cancel. Negative 1/4, positive 1/4, cancel. And then we're going to here. Okay. And the 1 over n with the previous term, which is a negative 1 over n, cancel. See, what do we have? We have a very simple. Okay. Now it's just 1, the first term left, minus the last term left. We cancel all the term in the middle. Look at it. So can we find the limit now? Definitely was the limit. And this approach 1 minus 0, right? Which is 1. So this 1 is the sum of the series. Okay. Therefore, we find that the sum of the series is 1, which is the limit of the partial sum, right? Okay. This is the first question. Let's practice another question. Here is the second question. Okay, so look at this series. Think about which way we can do. Of course, it's not a geometric series, right? we do not need to use the definition. Why? Because now we have two terms added together. This is a linear combination. So we can do this. Can directly use the linear property to break down this into two series. That's the first step we can imagine. So we use the linear property, okay, to break down into two terms or two series. Okay, so if I break this down now, what do we have? See, the first, this constant number, which is c, right? So we take it out. That's a linear property. So that's 3 times the first. The first is 1 over 1 times m plus 1. Okay, and then plus the second series, which is 1 over 2 raised to the nth power, 1 by 1. Okay, so the first 3 times, I say this equals 1. Why? Because we just did. Okay, so can we go back to question 1? See, 1 over n times n plus 1. We just use the definition. We get that the sum is 1, right? So we can directly use it. Okay, and let me see. I highlighted this equals this 1 because question, this is the result from question 1 we just did. Okay, we do not need to repeat. Now look at the plus, the second. Do you remember we also discussed this series before, right? In the last video, this is a geometric series. Why? Because we have n. Okay, if you imagine this is a geometric series, if you cannot see right now, we can break this down. Okay, in this way, we take 1/2 out, and then how many left? 1/2 raised to the n minus 1 power left. This time definitely you can see, right? So, and can you see now what? So this is a geometric series. Okay, that's a geometric series. We say what is a? A, the first term is here, right? A coefficient. What's r? R is the base, which is 1/2. See, and now we use the formula. We can find that the sum formula is S equals A over 1 minus R. Do you remember this formula? All we need is do this calculation now. So here the first is 3, right? The second, the formula, which is a fraction. The top is 1/2 minus R is still 1/2. Okay, so good. Let me do one more step. 3 plus 1/2 over 1/2, which is 1, right? And then we get the answer is 4. This is the second question. Let's look at another question. Here is the third question. And then now we have this series. Okay, we have the first term 2, the second 0.5, all these terms added together. So first, we have to think which way we to use. If we use the definitions too complicated, right? Can we use the linear property? Of course, this is not. Okay, just one single series. Do you think this is a geometric series? Yes. Okay, let me show here. I say yes. This is just a geometric series. Okay, why? Let's verify. So we check the ratio. What is the ratio? I use A2 over A1. What is this? 1/4. Okay, of course we found. The same I use this, which means A3, right? Over the previous term, A2.5. So we can do calculation. See how many you find it is still 1/4. How about the A4? So is this number over A3, which is this number. Okay, you use a calculator to calculation. See, is still 1/4, which means what? Can you see? Imagine all the ratio are common. Therefore, this is a geometric series, right? Okay, if it's a geometric series, now easy. All we need is this we find the parameter. So now we already find R is 1/4 comma ratio. And what the first term see easy is here, right? That's 2. Okay, now we have everything. If you like, I can write this general notation, which is sigma. Can you see? A, which is the first, is 2, right? Times the common ratio R is 1/4. And the power is n minus 1. Okay, you can verify this is exactly the same as this question showed. Okay, now all we need to do is use the formula. Okay, what is S? The sum. S, the formula is A over 1 minus R, right? So we know A is how many? 2. 1 minus R is 1/4. And then do calculation. How many here should it be? 3/4, right? Okay, and then is 8/3. See, that's the answer for this question. Let's practice one more question. Here is the last question. Okay, we have this series. Looks complicated. Okay, let's think about which way to use. And if we use the definition, too complicated, right? And this is not a linear combination, so we cannot use a linear property. The only way we need to think about a geometric series. Okay, do you think it is geometric series? Yes. Okay, why this geometric series? Okay, at least we can guess this is geometric series because see, I see the power n, right? In geometric series, the power is like n or n minus 1, whatever. Okay, so let me guess. This is a geometric series. But now we don't know what is A, the first term. What is R, the common ratio. Okay, we do not need to exactly expand into each term. Okay, we don't need to do that. We can do what? We can do manipulation. Okay, so we just manipulate a little. Okay, and so we can find the general notation. Follow the formula. Can we see? So how to do? I will show you this way. Okay, a little bit longer. I will leave the top power n minus 1, which means I leave the numerator no change. Why? Because remember, in the formula, the power, do you remember the power of the general term, which is n minus 1, right? So we still keep this n minus 1. And for the denominator, I will break it down into 4 times 4 raised to n minus 1's power. Okay, and this time, what we can do now? Good, we can merge this power, 2 power together, okay, into 1 power. Can you see? This time we have this, which means the summation 4, which means 1/4, right? Up here, and then times, put them together, which is I can do this. I can just put the -3/4, right? -3/4 is this. Now we have the power m minus 1, and this is just the power of quotient. Do you remember that? Okay, so this time definitely we know is geometric series, right? So where is A? Here is A. Where is R? Here the base is R. Let me write. So now easy to see. A is the coefficient. R is -3/4. Don't worry, -3/4. The absolute value of this is still less than 1. So these converge, okay? And therefore, we need to use the formula. What the formula? Let me write here. The formula is S equals A over 1 minus R, right? Okay, so I use the formula. Okay, see, we will get that this is the sum, which means 1/4, which is A, right? 1 minus R is negative. Don't miss this negative. -3/4. Okay, of course, we do calculation. See, what do we have? 1/4. Let me write it this way. The bottom is a 1 plus 3 over 4, which is a 7 over 4. We cancel 4. What do we get? We get a 1 out of 7. See, that's the answer for these questions. That's all. Thank you. I hope you enjoy learning on this topic. If you have any question, please leave your comment. If you like this video, please give me a thumbs up. Thank you for your support. Please don't forget, you are very welcome to subscribe to my channel for more videos. In the next video, let's see, we will move to integral test, which is another method to test convergence or divergence. Hope to see you there. Thank you. Have a nice day. Bye.